Get started. So thank you very much everyone for joining us today. This is the last webinar of our list of webinars we conducted in April. So during this particular kind of situation we are all in around the world, we wanted to share as much knowledge as we could with you. So we had one webinar every week, and today is the last of the April webinar series. So if you have any questions on the webinars we had in the past, then you can find all the replay videos on our website. So today we are going to talk about a very innovative solution we are introducing that allows you to monitor each plant individually in your breeding trial. So this is very exciting, and we are very happy to show you some of the results we got so far, and we are very excited. So today your hosts are Alexis and myself. If you've been with us on the last few weeks of webinars, you know us really well now, and as always, we are very happy to answer your questions. So Alexis, as you know, is the founder and CEO of Hiphen, and I'm the R&D director. So today's session is divided around 4 key pillars. We will talk about plant-by-plant monitoring. What do we mean by that, and why is it important? We will talk about sensors as well. So what kind of sensors can be used to do that effectively, and what can we do with UAV? And we'll share our experience with UAV with you on this topic. And lastly, we'll talk about Cloverfield, which is our data platform that can allow you to automate this type of calculation. The session will end with a Q&A session. So as Alexis said, do not hesitate to type your questions as we go through the presentation, and we'll answer them at the end of the session. So a few words about Hiphen before we launch into the plant-by-plant topic. We are experts in plant diagnosis. We are experts at measuring plants using a wide range of devices and sensors. We offer a wide range of traits. So if you're a breeder, for instance, and you're interested in a particular trait, it's very likely we've got it for you, or we can develop it for you. So we have a very large portfolio of traits that we can compute in Cloverfield. So we do a lot of different things, and today basically we are going to explain how some of these traits can be computed at a plant level instead of the traditional microplot analysis that we are all used to. So we really believe that this is a game-changing method because it gives you a lot more information about what is going on in your breeding trial, and we are really excited about this type of solution. What do we mean though by plant-by-plant monitoring? Just before we launch into all the details, I just wanted to precise that what we are talking about here is the ability to locate each plant in your trial. So here you can see 3 microplots, and the idea is to locate each plant and assess its performance during the growth cycle of the plant. So this is a very unique solution in that sense. And here is an example of how it all starts on the sunflower trial we analyzed for INRAE in France. So you can see on the left the trial orthomosaic, and on the right you can see a zoom in one of the microplots where you can see the little numbers are basically the ID of each plant. So here we've been able to locate each plant individually and then follow their performance date by date as we had a lot of UAV flights in this trial. From there, why is it important to work at a plant level? We believe that there are 3 key concepts and advantages to this solution. One is what we call here the early sorting, so giving you the ability to start sorting plants at a very early stage in your breeding program. And Alexis will show us what that looks like in a minute. The other advantage is to be able to analyze the variability within your trial with a very high precision level, and be able to dive into the genetic analysis at the level of details and granularity that was not possible before with high-throughput phenotyping solutions. And lastly, being able to evaluate the plant in its environment, meaning that you'll be able to remove outliers like you've never been able to do it before with this kind of solution. And we are very excited to show you some examples today. So with that, I'll pass on to Alexis, who's going to give us examples for each of these key advantages.
So thank you, Jess. So I think the first main idea, and I think the real reason why it's so interesting to make plant by plant, is what we call this early sorting. In other words, today phenotyping is really done at the microplot level. So a microplot being a kind of surface with few meter squares or a few feet square. And the first phases of your selection program was not available for such technologies as high-throughput phenotypings for drones or other sensors. Today, with this plant by plant, it becomes possible and achievable. So that means that you can follow up much more cultivars at a much earlier stage and really use this digital technology very early on your breeding program to take better decisions with more data. And that's really a very cool thing, I believe. So that's our main motivation, being able to help you on nurseries, as we had a lot of people asking us for that, and we weren't always able in the past to answer to those needs. The second thing is what we call hybrid sorting. So hybrid sorting, let's take a concrete example there, sugar beets. So in sugar beet, when you're having your seeds of sugar beets, you generally have 3 ways hybrids, and the genetics of those 3 ways hybrid is not stable at all. And what is really interesting for you, generally, is to be able to know if in your population, globally, the traits you're looking for, by example, resistance in Cercospora, which was a webinar we made, I think, 3 weeks ago, is acquired by all the plants in your population. So generally a microplot is between 20 to 30 plants. Or if there are some plants, because for genetic issues, that didn't acquire it in this hybrid making of your plants. And this is really cool because today we're able to give you not an average at the microplot level, but really a measurement plant by plant, and this measurement plant by plant means that you're able to quantify how much plants are really tolerant or resistant to the disease or not. So that's what we call hybrid sorting. And finally, the last reason is what we call outlier sorting. So to make it simple, a plant doesn't evolve the same way individually or in a population. And that's why greenhouses, phenotyping devices are awesome devices, but you really want to have things in the field to see how those plants behave in outdoor environments with competition at the same time of the same plant as them in the population, and at the same time against weeds, etc. Being able to monitor plant by plant in the field means you're able to know if each plant is having real competition or not, and how it reacts to this competition. So it gives you a better idea of this genetic behavior. It also enables you to remove all the plants that you don't want to keep for your genetic analysis. And that's really, really powerful. And what we've seen within RAE was that it does give you more statistical power than to match your trait with your genetics. So let's go and see some real example about of that, of how it works. So here is an example. So as I told you, we are much earlier in the breeding trail, where we have just one line. We choose sunflower, as sunflower is probably the easiest plant for plant-to-plant phenotyping. And you can see that here, well, between the different, for the first factor, competition between plants, you can really see that at early stages, you have emergence issues. So some plants that emerge a little bit earlier than others, and you don't have the same type of homogeneity on the right-hand side of your microplot and on the left-hand side of your microplot. Another example, you have one plant that lodged. does that mean when you have one plant that large that you should remove all your microplots? Does it mean that finally at the microplot level you need to take that into account, or can you allow yourself to follow each plant, and especially the plant that didn't lodge? And finally, it does enables you to locate and to understand what one plant don't emerge and what is happening when they are not emerging. So concretely, once I said that, that's how it looks like. I mean, in this first example, we just took it and we look at the projected surface area in meters square, and you can see that we're able to follow this. So we're able to locate in a GPS way, all in a global positioning way, all your plants, and we're able to tell you what is the surface, and this at every given time. That allows you also to be able to see more or less what is happening where you don't have emergence. So there you see that weed infestation starts where you didn't have plants, and then it can start to make competition. And because we're able to locate each plant, we are able to be able to follow up from one date to the other, and also we're completely immune to weeds. And so that's something that we could have been immune to weeds without doing plant by plant. We can always try to segment what is the plant that we want to the weeds. But actually, we found out that it's almost easier to do it this way. So to make a really plant-at-plant follow-up, and then to try to quantify all the other source of greens that are not the plants that we're looking at. And finally, what looks for me very important to tell you in this webinar is that once we have this positioning of each plant, we're able to match them from one date to the other. And so we're able to have the dynamics of each plant through time. And that's really cool, because you can see then some example by example of a plant that grows faster because it emerged faster. You can see if you have basically a quite homogeneous microplot or line row, or if it's quite heterogeneous. And then what you can do is, or you can choose to remove the outliers, or you can choose to take the median, or you can choose to study individually looking at what date it had as emergence to try to make some modeling, some kinesical modeling. So you can actually think of many applications on this plant by plant, and I would be very happy to, in the chat, to see what type of application you envision for you. But that was really to give you another view, a flavor of what can be done. Then once we finished the growth, we already made a webinar at microplot level on what we can do through senescence. I do believe that the main message that we want to give there is once your plant becomes bigger and bigger, well, you already have its positioning through the first phase, so you know where is the plant, but it's not necessarily the plant that you will follow anymore, but it's more going to be the organs. And so this works well when the crop doesn't tillers. For example, wheat. Wheat is a very complex crop to make a plant-by-plant follow-up, and we're going to see why later on. It is much more easy on crops like sugar beets and flowers, corn, sorghum, etc. Even if, be careful, sorghum does tiller a little bit. Yes, so some concrete examples from there. Well, with corn, so what we can do is first we detect each plant, we follow up the growth of each plant, then we can follow up the tassels, and we can, by segmenting the area that we believe being the area of a plant when it's big and that the green fraction, the cover fraction is almost close to 1. What are the areas that are senescing faster or not? On the case of wheat, well, what we can do is we can try to count the plant at emergence. So as Joss will show you later on, it's probably more with devices like Phenomobile or literal or handheld systems, etc. But this is something we're achieving today, every day for our customers. And then what you will follow is width spikes and stems. So this as well, we discussed it quite a lot last week on the Global Wood Challenge. It's not plant by plant there because we're not able to know from which tiller of which plant each head comes from, each spikes, but we're able to follow all the organs. And finally, sunflower, which was really the examples that we tried to show to give you a flavor in this webinar. Well, sunflower, there what we do is we follow the plant from emergence, and then we're able to follow the heads, so the heads that are appearing, and then the heads that are quite clear. Of course, you have, so it's not exactly tillers, but you can have some tillerings in this case. The way we deal with it today is that we consider each head, so we try to match one, we don't try, we succeed in matching one head with one plant. And if you have extra heads, well, we create new plants. If you have better idea on how to deal with those organs that you're able to count and that you're able to match with the plants in a better way, we're very happy to discuss about it and to hear what are your opinions. To finish, we can look at what type of sensors and devices we're going to use, and I let Joss present us that.
Okay, thank you, Alexis. The type of sensors there are a lot of devices and sensors we can use to achieve this type of plant-by-plant monitoring. Here we listed a few examples. So we have gantries on the left that are systems that can provide us with very high resolution images that can effectively do the job. The same as applies to the Phenomobile, which is in the middle of the slide here. The red robot you see in the middle of the microplot is a Phenomobile, which is an unmanned robot that covers each microplot without human intervention, and can also give us very high resolution images, and we can do a lot of fantastic things with this type of devices. We also have handheld devices. Here on the right, you see one example of what we call the literal kit, which is something we developed, co-developed with our partners at CAPT, which is a research unit here in France that includes Alexis, INRAE, and Hiphen, and other partners that aim at developing this type of innovative solutions to boost phenotyping solutions. So here is an example of one handheld device that can also do the job effectively. So these type of systems are very robust. They give us very high resolution, and we can do a lot of fantastic things, but they are very costly. Maybe not so much for the handheld device, but the robotic devices can be costly. That said, we still believe, and we continue to believe, that the UAV remains the most affordable device to use for high throughput plant-by-plant monitoring. So here we show you an example of DJI Mavic 2 Pro that we believe, as we explained in the webinar, the first webinar we had this month, that this is a very solid device to do the job. They provide very good resolution. It allows us to do the job very affordably, and we've been using this device very actively. So this is for us very, very important, because we can, with this type of devices that are now becoming cheaper every year, we see that a lot of clients try to internalize UAV acquisition, and we believe this is very important. So what we spend a lot of time on at Hiphen is to support our clients to internalize this type of skills. So we, for instance, train their teams to do UAV acquisition properly. And what I mean by properly is that we train them on all the flight parameters, that you can think of that will ensure that the data that comes out of the UAV acquisition can be processed effectively and matches the highest quality possible. So we really focus heavily in that step around the UAV acquisition protocol. And we've got a lot of experience and gathered what we call internally the standard operating procedures, the SOPs, that will ensure that you acquire your data in the best way possible. So we have a process in place to accompany you in the first phase around the protocol, and then on the data acquisition. If you in-house it and do it yourself, then we will be with you along the way to help you. And the last part of this process is for us to automate the data processing. So the traits and this plant-by-plant monitoring is something that we process automatically in Cloverfield, which is the name of our data platform that this platform does a lot of things for us. It first processes the data, so it's first a data processing engine that is very powerful and can compute the data for us, and allow us as well to access the results in a very cool web interface that allows you to inspect your microplots in a lot of details. And get your results, statistics, images, and so on in one place. And that really allows you to run the analysis you need for your applications. So we really believe that we have all the steps covered for you to do all of that very effectively. And for us, it's very important because one of our key mission is really to help you to scale and get all of that effectively. So here's an example of the web interface, Cloverfield, that you can use to inspect each microplot. So you can click on one microplot, see what the microplot looks like, see all of your statistics and results per microplot. You can do a lot of analytics as well, a lot of graphs and so on that can allow you can facilitate the job for you. So this is pretty powerful, and this is a tool that runs and is used across a lot of countries worldwide and processes millions of microplots each year. So it's a very robust and powerful solution. And finally, we really believe that what we showed you today with Alexis is typically the type of solution that we are very proud of, because it's a bulletproof solution. It's something that we really strive to make sure that it works in a lot of different field conditions. It's not something that you have to reinvent or customize in a lot of details every time you move from one crop to the other, or you have a new field condition that comes and disrupts your data pipeline. So we really try to make it very, very efficient and effective, and it should work across the different field conditions. Of course, customization will always be needed, but this customization, we know how to master it and make it easy for you. The second mission is to be transparent. This is something we've done this month with all the webinars and knowledge sharing sessions. I hope that you really trust us in that sense, that we are very transparent with you, and for every proof of concept we work on, we really engage with you on the methodology section, and we really want to ensure that you understand the methodology and that you're part of it, so that there's no kind of black box feeling that you don't know what's going on in the data processing. And finally, being able to scale, being agile, so that you can apply this kind of method to your entire territory and footprint is very important to us. Last word for me, we tend to do that with a lot of clients, that if you have an application that comes to mind and you say, okay, that'd be interesting for you guys to look into something for me, then we'll be happy to look at a sample data set, process it for free, and see what the results would look like, and send you a tailored proposal. So if you have any thoughts on that, do get in touch. We'll be delighted to talk about that with you. And before we move on to Q&A, the next web meeting for us will be Ask Me Anything session. I don't know if you're familiar with it, but it's quite cool. It's a session where we basically throw Alexis and Lee in front of you, and you can ask them any kind of question related to phenotyping. Of course, it's not to ask Alexis about his love life or personal life, but if you have anything that you'd be interesting to have our opinion on, so any kind of phenotyping activity and application you're interested in that you want to get some Hiphen expertise on, then this is a good place to start, and we will be sending you an invite for that very soon. So we are very excited about that, and you'll hear more about that in the coming week. With that, we can jump on the Q&A session for a few minutes. We'll read the question that you've written, and if you have any questions, please continue typing them in the chat box.
So Alexis asked for the first question was, these are UAV images. Is it really good resolution? So the answer is yes. So I would propose you to refer to our webinar on plant-to-plant counting. On plant counting, which was the first webinar, we need to have a lot of resolution to do this plant-by-plant follow-up. And this is something important. So which makes me jump on Lee's question on should we only use Mavic drones or the camera standardized enough? The answer is most of the plant-by-plant today is done by RGB images. So with RGB drones, so cameras, we are basically able to work with any type of drones if the images are of good quality. So it's more a kind of hardware issues than a kind of software issues with RGB cameras embedded in drones. Main questions you need to ask yourself, is it a global shutter, mechanical shutter, a rolling shutter? So by example, there's a big debate lately, should you more use a Mavic 2 Pro or a Phantom 4 Pro V2? So the Phantom 4 V2 has a wider opening angle, which is not good, but has a mechanical shutter, which gives you better images than the Mavic 2 Pro, which has better lens with Hasselblad, but it's still a global shutter, a normal global shutter, and you have some resolution issues. So basically, yes, we're able to work with the material you bought, as long as it's good quality material, and this is something we can look at. That's why we propose some free trials, because we get the data, we put it in our pipeline, and we see how it does. And if it doesn't go well, we make for you a free audit explaining you why it doesn't go well and what you should do to answer it. So that's this question. We have Alexis that told us that it could be also great for vegetables, so things like onions and salad. The answer is yes. So today we focused on breeding, and we are not working that much on onions and salads for breeding. We are working with those two crops, however, on other types of project where plant by plant is also achievable, and we have such type of projects. Akira Kuakino is asking, this is essentially for breeding, or can we check the level of competition with spontaneous plants? So this webinar was really made for breeders. So we spoke about breeding applications where I believe we have the most business and the most economical opportunities. Of course, for some more research questions such as competition between plants, those solutions can be easily adapted, and we would be very happy to work with people that are looking at some quite research questions and to see how our algorithm and our method can match their questions and to answer it. Jérôme was asking, what is Phenomobile? So Phenomobile, we presented it in this slide. So it's basically what we call in France, so in the Phenom environment or French plant phenotyping network, all the unmanned phenotyping robots. You have two types of Phenomobile, the V1, which is in the picture here, and a V2 that is able that has robotic arms that is able to go much further on plants like maize, so to go up to 4 meters high. Finally, I see another question with Malcolm Morrison, which is asking what is the resolution of a camera on a Mavic UAV. So I remember it's a 1-inch sensor, and I think, but I'm scared to say stupid things, so I can check it up very quickly. I'm opening my files. On a Mavic, you're having 20 megapixel resolution. So it's 5,472 times 3,648 pixels. And that's already quite good. So it's a 1-inch sensor, which is really nice. Huh? Be careful, Mavic Pro or Phantom, not Pro, Phantom 4 or things like that, has a much smaller, how do you call it, sensor. And the quality of the images are not that good. So really it's Mavic 2 Pro, Phantom 4 Pro V2, or then we can go into the ZenMuse types of gimbals, but also on the ZenMuse types of gimbals, you can have nasty surprise sometimes. So please try to make some trials, try to make some acquisition, come and ask us feedbacks, and we would be very happy to provide them. So Sebastian is asking, can we consider this approach for wheat with a precision drill despite the problem of tillering? The answer is we didn't do it. I'm quite sure that we cannot envision anything with drones today, not enough resolution. So it's really mainly a problem of resolution, because with drones, you cannot fly below 10 to 12 meters because of wind effect and also stability compared to the type of terrain you have. And you will not have enough resolution to do such things with a drone today. Maybe it will change in the couple of months with new innovation. However, using systems like Phenomobile or handheld device, yes, we can envision being able to locate things that are corresponding to plants at each phase, and then try to match them. So this would really be a proof of concept that we would do together with no guarantee of success. It can have a price that is a little bit higher than what we generally propose to people. But I do think there's really interesting things to do with wheat. It's the most challenging crop. I hope but we would be really, really happy to work with you on that. So I think that's basically all the questions I saw. Just, did you see other questions?
No, you covered everything.
Cool. So if you have no more questions, we can finish this webinar session now. And we really thank you for having been with us for those 5 webinars we made. If you haven't seen all our webinars and that you're really impressed by the quality of them, we invite you to go into our website and you can replay all the webinars for free. So please don't hesitate. And I would be very happy to see you, all of you guys, with Lee in basically 20 days, May the 20th, to speak about all the topics you're interested in for phenotyping. So yeah, so we can't wait to see you by then. Bye-bye.
Thank you, everyone. Bye-bye.